Next, we will proceed with determining the stress limit for the precast sections at the transfer stage and at the service stage. There will be limits for the compressions and tensions. It is given that the FCK for the precast sections is 50 Newton per mm square. Assuming the transfer is done at 25 Newton per mm square, the compression limits will be 15 Newton per mm square and 30 Newton per mm square at transfer and at service. It is calculated by the 60% of the concrete strength at that particular instance. Then we need to determine the tension limits, which is defined by its FCTM, which the formulas of FCTM can be referred from Eurocode 2, Part 1, Table 3.1. Assuming that the precast elements is fully prestressed, no tension stress is allowed. Now we will proceed with determining the loading. There will be self-weight of the beam, which is calculated by the factor of safety times unit weight times the area of the beam section. The unit weight is given as 25 kN per meter cube. The factor of safety is referring to the serviceability limit state, which is equals to 1.0. The moment minimum due to the self-weight of the beam is calculated from the equation here, which is equals to 837 kN meter. Next, we need to calculate the self-weight of the slab plus the formworks. Assuming the formworks is about 10% of the self-weight of the slab, that means we will need to calculate the self-weight of the slab multiplied with 1.1. Again, it is the factors of safety times unit weight times the area of the slab. Plus that 10% of the formwork, you get 4.4 kN per meter. The moment caused by the self-weight of the slab and the formworks is calculated based on the formula here, which is equals to 316.8 kN meter. Then we will have to calculate the service load. It is QK that given in the questions, 18 kN per meter. The moment caused by the service loads is given by the equation here, which is 1296 kN meter. Having all the values obtained, you have the factors obtained from the questions. The properties of the concrete is calculated in the previous calculations, and the section modulus is calculated from the geometrical properties at the early stage. Area also is a geometrical properties, and there will be 3 types of moment, as well as the shrinkage and thermal stress. Substitute all these values into the 4 equations of Magnol, you will get this. The maximum eccentricity will be defined by the y bottom minus the cover, which this y bottom is referring to the precast section. You get 384 mm. This is meant to calculate for the Magnol diagram for the midspan. There will be another set of data where you're going to use it to calculate for the Magnol diagram at the support. For the support here, as it is simply supported member, the moment will be equals to 0. The rest of the data will be the same. Substitute into the equation here, you get these 5 equations. Your next step is to plot the Magnol diagram. The first diagram here shows the Magnol diagram for the midspan, and the second diagram here shows the Magnol diagram for the support. The solid line here represents it is greater, while the hidden line here refers to the regions which is less than. If you observe the Magnol diagram here, the feasible regions as indicated by this line will be greater, and the feasible regions as indicated by the line here is also greater. However, the other two lines below this line is lesser. You will see that there is no overlapping regions between the lines here. That means there is no feasible regions for the midspan. In this case, you will have to redesign these sections until you have worked out a feasible regions within the midspan. As for the support here, the Magnol diagram looks nice. The header line means lesser, header line means lesser, solid line means greater, and solid line means greater, and the maximum eccentricity means lesser here. There will be a regions of feasible region. That means for the support here, you can propose appropriate P and E within the regions here. However, the midspan and the support, they both appear in the same beam section. You only can obtain a feasible regions for the support, but you are unable to obtain it at the midspan. You will need to redesign the section so that you can find a common regions for the support and the midspan. If you would like to stick constant for either the P or the E. As it is mentioned that the precast member here is considered as a pre-tension member. It is easier to be constructed with a constant E throughout the member. Otherwise, you will have to use the deflected tendon methods to adjust the E. This is also possible, but the only requirement will be you must find a feasible regions at the midspan and also the feasible regions for the support. Propose appropriate P and E, which is workable so that the sections will be safe.